So nth roots, this is what we're going to be getting into. We've already done this a little bit with some of our review lessons. It would have been like 6.1. Okay. We're going to be working with this right here. So it was the nth root of x to the m. You guys remember that? Okay. I put it up on that board. I said this is going to be really important. This is the same as x to the m over n. Okay, we're going to be digging into this a little bit more today. All right, but when we're talking about nth roots, this is what we're talking about, nth roots right there. So sometimes that n is going to be a 2, sometimes it's a 3, sometimes it's a 4. Nth roots, okay? That's where we're starting. So this is the first thing. This is really just the definition part of this page. You can see there that a to the nth is a, and then we just take the b and we put it inside, and that becomes our radical. And then the n becomes our index. Okay? So another way to think about this is a concrete example here. If we have negative 2 to the 4th, what that looks like if we stretch it out is like that. You guys agree that that would equal 16? Yeah, because negative 2 times negative 2 is going to give us a positive 4, right? So then we end up with 4 times 4, which is 16. Okay, so what this would mean if we were going to put this into words, we would say that negative 2 is a 4th root of 16. Because negative 2 times negative 2 times negative 2 times negative 2 equals 16. It is a 4th root. Another way to think about this, as far as like what the things are at the top, this is 16 to the 1/4. Okay, so 16 to the power of 1/4 is the same as the 4th root of 16. Hey, but there's another one. There's another 4th root of 16. We've got negative 2. What else? Yeah, what if I did this? And we just took all these negatives off of here. Would that still equal positive 16? It does. Okay, so what that does is it puts us into that whole plus or minus world. And we say it's plus or minus 4. The 4th root of 16 is positive or negative 4. And that's because we are multiplying it by itself an even number of times. Okay, those properties of negative numbers, a negative times a negative gives us a what? A positive every time, right? So if we have our index as an even number, then we're going to have two solutions. We're going to be in that plus minus world. Okay? This is a really good thing to talk about, especially in terms of your calculator, okay? So this is something we've already written down. It should already be in your notes. But just a reminder, the number inside the radical is called the radicand. The index is the number that goes outside of it, okay? Remember when we do square root, like if we do the square root of 16, we don't actually put a number here, but what number is hiding right there? A 2, right? Okay? So that's the index. The index is 2. It's a square root. All right. Now, 16 has 2 square roots. And hopefully we know that by now. Because 4 squared, 4 times 4, positive 4 times positive 4 is 16. And so is negative 4 times negative 4. Okay? But those of you that have your calculators out now, if you don't, get them out. And I want you to put in your calculator the square root of 16. What's it tell you? It says 4. Does it say also negative 4? Does it say plus or minus 4? No. And that's because your calculator is programmed for the principal root. It's only going to tell you the principal root. Okay? So you have to know that, oh, that's an even number. I could have two solutions here. The square root of 16 could be positive 4, but also could be negative 4. You have to know that. Your calculator is not going to tell you that. All right, this is going to be one of the biggest takeaways of the day. All right, so you have this chart in your notes. Okay, go ahead and take some time, and I want you to fill this in, and then I'm going to add some extra little notes to it here in a minute. Okay, this first part right here, what we're saying is that B is positive. Okay, so if you want to add that, we're saying it's positive. Okay, another thing I want to add to these notes is going to be up here, and we're talking about the nth root of B. Okay, so when we look at where the n is, that's what we're talking about. Like when it says n is even or n is odd, that's where the n is going to be. Okay, for the middle one, b is 0. That means that it's 0. Like what is inside the radical is 0. Hey, on the bottom one, we're saying that it's negative. Okay, I just flip-flopped those. Sorry. That should be negative. That's positive. My fault. Okay, less than 0 is negative, Mr. Nooch. Okay, so here's what this means. If I'm gonna use 25 because that's one that Aiden had with us the other day or just earlier, and we're gonna go the square root of negative 25. Can we do that? Like we know the square root of 25 is what? 5, right? Okay, so let's be like, all right, negative 5 times negative 5. Is that gonna work?
Nope.
Because what's negative 5 times negative 5? 25, right? So it's not going to give us this negative 25, right? So this is why it's no real roots. Now, what this says is no real roots. It doesn't say no solution. It doesn't say impossible, right? Because there is something that we're going to work with later called imaginary numbers where we can do this, okay? But right now, we're going to put no real nth roots, okay? If it's odd, so let's use 8 for this one because that's a nice easy one, and we're going to use cube root. You guys agree that a 3 is odd? You guys agree with that? 3 is odd, right? Okay. This means we're going to have one solution, and here's why. Does anybody know the cube root of 8? What times itself 3 times gives us 8? 2. Okay. 2 times 2 times 2. That gives us 8, right? Well, if I make each of these negative 2, am I going to get positive 8? No. I'm going to get a negative 8, right? Because negative 2 times negative 2, that would give me a positive 4. But then if I multiply by a negative again, it's going to turn it back into a negative. So that's not going to work. So the only answer that I have, the only solution that I have, if it's odd, is going to be that one answer, which in this case is 2. Because 2 times 2 times 2 is 8. Okay, that makes sense so far? The cube root of 8 is 2. If we were to do 27, it's just 3. It's not positive and negative 3, it's just 3. Okay? All right, if b is 0, that means there's one nth root. Okay? Well, what's the square root of 0? What times itself gives it 0? 0, right? Even if we put like a 24 right here, the 24th root of 0, well, if I string 24 zeros together and multiply them, what am I going to get? 0. Okay, that's the only answer. It's always going to be 0. Okay, it's the same thing for this one. It's going to equal 0. So if your b is 0, if the number inside your radical is 0, it's 0. You only have that solution. Then if it's positive, okay, if it's positive and we have an even number, so let's use 25 again. And we have the 2 there because we're talking square root. We're going to have 2 real solutions. We're going to have negative 5 and positive 5. Okay, or you can write that as plus and minus 5. We good with that? That's something you guys have been doing for quite a while with square roots. The only thing that's going to be different now is instead of it just being a 2 and only square roots, it might be a 4th root or a 6th root. Okay? So you need to know that if that number, if your nth root is an even number, you're going to have 2 solutions. It's going to be plus or minus something. Okay? If it's a positive number and you have an odd nth, so let's use 8 again, and 3, okay? Now, oh, that was supposed to be negative, sorry. Okay? got this flip-flop. This one up here, negative 2 times negative 2 times negative 2 does equal. Okay, this one's positive, and it has odd int. So now it's just got to be 2. 2 times 2 times 2. Okay, negative is not going to work because we know that if we have 3 negatives multiplied by each other, it's going to give us a negative number. Okay. Any questions on that chart? This is going to be something that's going to be really, really valuable as we go forward. All right, knowing that now, what I want you to do is on your note sheet, I want you to simply write next to each of those. Let's just do the top 6. So it starts with the cubed root of 8 and then goes down to the 4th root of negative 81. Don't do the ones that have all the exponents and stuff. I just want you to write how many solutions there's going to be. Is there going to be 1 solution, 2 solutions, or more? Okay, ready? Go. So you're doing these. Okay, how about the first one? Are we going to have 1 solution, 2 solutions, or no real roots? What do you think? Hold it up, 1 or 2. Everybody has fingers. Gus says 1. Hey, it's 1. Because our nth root is odd, right? So in this case, the cube root of 8 is 2. Because 2 times 2 times 2 equals 8. Okay, the next one. Yes, Gus?
So if the radicand is not zero, or the radicand is not 0,
Mm-hmm.
and f is odd, it will always be 1.
Yeah. Yep. Yep. You can put it that way. Yep. Gus said if the radicand is not 0, so a number greater than 0 or less than 0, and the index is odd, we're always going to have 1 solution. That's correct. Okay. How about the next one? What's the cube root of 0? What's that, Ian? Cube root of 0 is 0 because 0 times 0 times 0 equals what? 0. Okay. How about the cube root of? Oh, I've got a negative 8. The cube root of negative. Can I have a negative in there if I have an odd index? So can I have a negative number in there? Yes, I can. Because negative 2 times negative 2 times negative 2, does that give me negative 8? It does. So my cube root of negative 8 is negative 2. Okay. How about the 4th root of 81? If you want to, we could do a factor tree for this. Or we could just think about the factors of 81. However you want to do it. 9 and 9. 3, 3, 3, 3. Oh, there's my group of 4, right? So what's the 4th root of 81?
3.
It's 3, but we have to notice that, this is an even number. So what else could it be? It could be negative 3 too, so it's got to be plus or minus. Okay, because 3 times 3 times 3 is 81, but also if we did negative 3 times negative 3 times negative 3 times negative 3, we're also going to get 81. We good with that concept there? All right, how about the 4th root of 0, James?
0.
It's 0? Just like the cube root of 0 is 0? It's the same thing? Yeah, because 0 times 0 times 0 times 0 is 0. How about this one? I've got a negative radicand, but an even number. So remember, the even number kind of cancels out my negatives, right? Because a negative times a negative is a positive. So what do I put for this one? What do you think the 1 solution is, Gus? 3? Positive 3 or negative 3? If I do negative 3,
Well, I said 2 solutions. Now that you said the even cancels out the negative, would it be
9 times 9 is what?
81?
81, right? It's not negative 81. So that doesn't work. Are we going to be able to do this? No. So we put no real root. Okay? Don't put none. Don't put NA. Put no real root. Okay, if you want to put NRR, I guess you can if you're really lazy. No real root. There is an imaginary root, okay? There is. We'll get to that later. It sounds wild. It sounds like fake math because, imaginary means imaginary. Imaginary numbers are a real thing, which sounds counterintuitive. Okay, now we're going to start doing these. So we have to keep this same thing in mind, okay? So now I've got the square root of 25x to the fourth, okay? What type of number is my index? What do I have in my index right here? What number is there? Hold it up. What number? Square root, it always defaults to what? 2. Okay, we're never going to have a single root because then that would just be the number itself, right? We wouldn't even put the radical. So a square root. So there's a 2 right there. Okay, and then inside my radical, do I have a positive number or a negative number? Positive number. So look back to your chart. I've got a positive number inside my radicand. Okay, and then my in value is even. So we would be talking about this section right down here. So how many solutions am I going to have? 2. We've already kind of taken care of that for you here with the plus minus. So I know that it's going to be plus or minus. And then we can think about this as the square root of 25 and the square root of x to the fourth. So what's the square root of 25 again? Russell, what's the square root of 25? 5. So we're going to have plus or minus 5. And then what's the square root of x to the fourth? If we were to break that apart. X squared. Okay, look at this. Ready? Some of you are looking at me like, how'd you do that? How many times is 2 going to 4? 2. I'll talk more about that in a little bit. But that's our final answer right there. Positive or negative 5x squared. Okay, how about this one? What is the cube root of 343? Well, first of all, let's do this. Do I have an odd or even index? 3. Is that an odd number or an even number? Odd number. So I'm going to have one solution here. Not going to be plus or minus. It's going to be one solution. So what is the cube root of 343? Ready? Now, say it. You can't, right? I mean, some of you hope. Okay, it's 7. Good job. It's not 6. It's 7. Okay? No, it's not 6. It's 7. Not 6 or 7. It's 7. Okay? But if you wanted to figure this out in your calculator, you would need to find the button. Some of you have this, like a cube root button. Otherwise, you have to press 3. And then you have to find this button where you have like the x and then the radical. And then you put your number in. And then you press enter. Okay? And that's going to give you 7. So this is going to be 7. And then what is the cubed root of a to the 18? Okay, I'm going to rewrite this. This is where I wanted to show you this a little bit more, okay? So I'm going to rewrite this right here. This is 343 to the 1/3 power. Okay, writing it to the 1/3 power is the same as the cube root. So then I can also do this. This is a to the 18 over 3. Okay, and this is b to the 6 over 3. Okay, now these guys right here are just fractions that you've been simplifying since you were in like 5th grade. 18 over 3 can simplify to what, Gus? 6. 6 or 7. So that's going to be a to the 6th. B simplifies to what? Or yeah, the 6 over 3 simplifies to 2. (18 thirds) Oh yeah, sorry, that's the wrong number there. That should be 7. I got confused with all the 6, 7 jokes. Okay. Give me like a thumb gauge right now. How, like, does that make sense what we just did there? Okay, especially the highlighted part. Like, do we feel good about being able to do this? Okay. All right. Now, I know, like, figuring out the cube root of 343, some of you would just got to work on that, like mental math stuff, or we got to get better at using our calculator. Okay? All right. Oh, did you get it? Yeah, I got confused. It's actually 7 because somebody made a 6, 7 joke, and then I wrote down 6 instead of 7. But 7 times 7 times 7 equals 343.
All right, yeah, someone made that joke. Yeah, it was you. Someone back there.
Okay.
No, I literally just said.
All right. Now, the next one. Don't write anything down yet. I want you to just use your eyeballs and make observations about the things we've really been focusing on here.
So you type whatever that is.
Okay? So the first thing I want you to do is look at your index. What do you have out here? What kind of number do we have? And then look inside here. Look at your radicand. What type of number do we have there? And then take 10 seconds. I want to talk with a neighbor. Hey, look back at your chart. Talk with your elbow partner. What do you think we need to do with this? How many solutions are we going to have? And then where do we go from there? Ready? Go.
So even if it's like, you said.
All right, what do we notice about this? You want to take a stab, Riley? It's negative, yeah. Why is that a problem, though, here?
Because there's a 2.
Yeah, because our index is an even number, and our B, which is negative 289 right now, that's negative. Can we do that? Not right now, right? So what do we put?
No real root.
No real root. Hey, one thing Gus was asking about his calculator here, so I'm going to take a picture of his calculator and just make sure we're all on the same page here.
Because the index is positive, or not positive. I mean.
Okay, so if you have a calculator like this button right here is the one that you're going to use for this. Okay, so if it's to the 4th power, you're going to have to press the 4, and then you have to go up here and hit second function, and then you hit the caret, and then you type in your number. Okay, the caret is like the thing that makes it be an exponent. Okay. All right, next thing we're going to get into is this. And this is something that we've already really been doing. Okay, we're just using different terms. So remember, we had it written down like this. X to the m over n equals the nth root of x to the power of m. You guys remember that? Okay, we did that last week, part of our radical review. That's all they're doing here. Okay, so if we have x to the 1/2, it's just the square root. Because remember, there's a 2 that's hiding right here. And there's a 1 that's hiding right here. You guys remember that? Head nods, thumbs, yes, maybe so. Okay, there we go. Body language is good. Same thing here. There's a 1 that's hiding right here. Then we put the 3 there. So this is the same thing. All right, we just want to be able to communicate that this is a square root, this is a cube root. Then we just start using the numbers. The 4th root, the 5th root, the 6th root. Okay, any questions about that? Okay, here's one thing that you can't say. All right, if we are communicating like the 5th root, you cannot say 5 square root of x. Because the way that would look is 5 square root of x. That's not a 5th root. This is 5 times the square root of. This is different than this. Do we understand that? Okay, they're two very different things, okay? And that's a semantical thing, like how you say it, but it's a really important thing. Okay? All right, so now using our rational exponents and what we know about that, if we have 16 to the 1/2, if we have 16 to the 1/2, how can I rewrite that into a radical form? Right now it's in rational exponent form. How can I rewrite this into radical form? Okay, so remember we have x to the m over n, and we can convert that to x, and then the m stays on the x, and then we have the nth root. Yes, ma'am. Okay, we're going to put this into radical form. Where's my 16 going to go? On the outside or inside? On the inside of my radical, that becomes my radicand. Okay, where's the 1 go? Where's the numerator go for my rational exponent? Where's this 1 end up going? It's technically right here, right? On the 16, but we don't need to write it. And then where's the 2 go? Yeah, that becomes our what? What word do we use? It becomes the index. Okay? That becomes the index. And with square root, we don't really write it, right? We don't show that because it just kind of defaults as square root. So that's how we would write that in a technical way. Okay, how about negative 27 to the 1/3 power? How about let's just only write it in the radical form. We're not going to solve it yet. So put your pencil to paper here.
He's using that as a prime example.
Okay, this is what Brady did. You guys agree with Brady? He's got the cube root of negative 27.
What does that say? Dude, just
Hey, I love this. He took the denominator and he made it his index.
Is that a 9?
Hey, the 1, well, we just put it here because negative 27 to the first. Can we do this now? We've got a negative inside our radical. Can we do that? We'll get to what he has down below here in a minute. Can we do this? Right? Why, Riley? Why can we do this? Good, because our index is odd. Okay, so now Brady, what are you doing with the 9 and the 3 down here?
Tree.
Yeah, he's doing a factor tree. 9 and 3. This is a 9. Okay, he already has a 3. We're going to bring that 3 down. 9 times 9 breaks into what? 3. But what are we missing here, Brady? Negatives. Yep, this should be a negative. Okay. And really, they're all going to end up being negative. Okay, because negative 3 times negative 3 times negative 3, that's what gives us that negative 27. Okay, so this one would be equal to negative 3. Okay, how about this last one we have here? Rewrite it in radical form. All right, hey, great little exchange back here with Gus. All right, he's like, all right, well, the 4th root of negative 81. And like, all right, we've done this 81 thing a few times. Okay, so it's going to be 3. And then because it's negative, I put a negative there. Well, if I do that and plug that into my calculator, negative 3 times negative 3 times negative 3 times negative 3, that's going to give me positive 9 times positive 9, which that gives me a positive 81, right? So what do we write for this one? No real root. Good. No real root. Can't do that. Okay. This, I don't really love this because it's the same thing as what we've been doing, just with different letters. So we're going to stick with the M and the N. Are we almost done? Okay. Well, we're going to do this quick. I want to show you this, and then we'll be done. Okay. So we're going to do the nth root of x. Here's what I want to tell you. It's the same thing. Remember how we can do this first step? Okay, we can take the rational exponent. We can turn it into the radical form, right? You guys feel okay about that? We just did that earlier, right? Okay, well, what this is telling us is that I can take this m, and I can put it out here too. You don't have to. You can. Okay, it's another tool in your toolbox. There are going to be certain problems where this is easier. Okay? Like if x was a 2, and this was a 3, if there are going to be certain numbers here where that's easier to do it that way. But then like this example down here on the bottom, if we didn't do that, okay, on the example on the bottom, it would be the cube root of 125 squared. Who knows 125 squared right now? I don't, okay? So by breaking this apart, I can find the cube root of 125 first, which is 5, and then square it, which is 25 as our answer.